I should pay more attention in pre-cal, that I will remember the trig unit, the circle unit, and then the graph function. So I would know my speed negative s minus 2 all square and its derivative negative 2x plus 4. So I will know I have a maximum speed that I should not cross over, so I would not die here.
I'm so sad. My horse is so dying. Oh, I'm disappointed in so much in this life. I don't want to disgrace his name any further. He always wanted me to go to the moon and become the best president.
Okay, so I am the Frost and I've just died. So for anybody didn't catch this, this is the velocity of my speed. So as you guys study in a pre-cal, a straight line with this will have the constant a constant slope y to the x. This is a constant slope for the straight line. But for this parabola like this, you can the slope is changing, is changed. So we need to find the derivative of this. So how to find the derivative of this equation? You will take dvt over dt, and you drop a degree of this, so it will be equal negative 2, and in the inside you keep the inside, and then you find the derivative of the inside. So t will become 1, and negative 3 will become 0, and then phi, since it's a constant, it will become 0, and then you will get negative 2 t negative 3. The 1 when the constant is disappear, and you will get the negative 2t plus 6, and the derivative of velocity will equal acceleration. If you remember, the acceleration is the changing of speed. So this is the velocity graph. I start at 0, and then I go up, I go up until here. This is the maximum point. So at this point the velocity equals 0. So at this point velocity is right here equals 0. And then after that my speed is slow down. My acceleration decrease until I die right here. So this is vt. So my acceleration will look something like this. So it decrease until 0 right here, and then it decrease here. So this is what it means, the derivative of an equation.
My horse is dead, but now I must travel the limits of e to the x, so I can reach the limits of infinity and become the greatest president ever. I want to be the very best like no one ever was. For my horse, of course. Time to get to work.
I wanna be the very best, like no one ever was. To catch them is my real test, to train them is my cause. I will travel across the land, searching
Bush is following the graph of e to the x, we can take the limit of e to the x as x approaches infinity because so the limit is the value x approaches as no, not x approaches, but the limit is the value a function approaches as x approaches a certain value. And so in the limit of e to the x as x approaches infinity, it'll also approach infinity. And it goes up and up forever like George Bush.
Hey guys, it's Darth Vader, and I'm here to explain one of the primary techniques of calculus, integration. So in this situation, Darth Vader is trying to reach the core of the moon using the ship that he hijacked from George Bush. And he knows the force. In this situation, we're saying that the equation for force is 1/2 x, and then this is the graph of force. But he wants to know the work done because work is FD, force over a certain distance, and that's what's really important to him because he's starting on the surface and going to the core. And the force is changing, which is really what calculus is about, calculating values that are changing, and they're not just constant the whole time. And one of the ways that we can determine the work that Darth Vader needs to do is through integration. So you have the graph of force, 1/2 x. Darth Vader wants to know the work done, so you take the area under the curve and you do an integral. So what an integral is finding the area under the curve. You write it with this notation, that big S, from 0 to 10, which is from the surface of the moon to the core. And then you plug in the equation for force, which I said was 1/2 x, and then you always end it with a dx. So that's how you write an integral. And then I'm going to show you how to calculate. So Mon already talked about what a derivative is. Now I'm here to show you an integral, which is essentially an antiderivative with a couple more steps involved. So instead of doing a derivative, the antiderivative, we need to raise the exponent a degree. So we have 1/2 x, we need to make it x squared, and then you divide by the reciprocal. So we're going to get 1/4 x squared. And that's the antiderivative. And now you still have the bounds from earlier, 10 to 0. So the way you handle this is you plug the top bound in to the equation, then you subtract and you plug the bottom bound in. So we're left with 1/4 10 squared minus 1/4 0 squared. So really that's just 1/4 10 squared, which equals 25. So Darth Vader, through the power of calculus, knows that he needs to do 25 joules from the surface to the core of the moon to reach his end goal.